Okay, today we're going to talk about our second tab in our foldable, that is Unit 13, Families of Functions, and the second tab is called Exponential Functions. And just like yesterday with linear functions, we're going to talk about things like zeros, domain, range, and stuff like that. That really all the functions, if you know what those mean, you can look for them in a graph or look for them in the actual equation of the function. Okay, so exponential functions are written in the form of a b to the x, which I wrote up top. A is your y-intercept, which we'll find like we normally do. When x equals 0, we know our y-intercept. And b is what I call the base multiplier, what's getting multiplied over and over and over again. And I'll show you in a table what that looks like. And again, if you have those two things, you can write an exponential equation for a function. Okay, so here's our first example that we're kind of talking about. Here's a table. I'm going to explain what makes it an exponential function. Okay, if you look at the x values, they're normal. We're counting by ones, so -1, 0, 1, 2, 3. But notice the y values. Okay, yesterday with linear functions, when you went from one y value to the next, you were going up by the same number. You were adding. Okay, so if you kept adding 2 each time to the y values, you knew you actually had a slope of 2, okay, as long as you were counting by ones with x's. Notice on these, though, you're not adding the same number each time. Okay, to go from 3 to 6, I add 3. From 6 to 12, though, I'm adding 6. So you're not adding the same number each time. So therefore, it can't be linear. Okay? What I do know, though, is to get from 3 to 6, and 6 to 12, and 12 to 24, you are multiplying by the same number. You are actually multiplying by 2 each time. That's what makes this an exponential function. The fact that to get from one y value to the next, you're multiplying by the same number. So since it's exponential, we know it's in the form y equals a b to the x power. A is your y-intercept. So if you look in this table, your y-intercept occurs when x is 0. So your y-intercept is 3. Okay, so I'm going to go ahead and write that in. And b ends up being the number that you multiply by each time to get from one y value to the next, and I called that the common multiplier, and that number is 2. Okay, so that would be your equation, okay, the exponential equation for this model, okay, for this table. If I were to show you a graph of this, okay, which I want to explain, okay, you can graph it in your calculator. You're going to find the graph looks something like this. Okay, it's going to look something like this. So a few important things about exponential graphs. Number one, their domain. They still go on forever to the left and right. Okay, all the x's to the left and all the x's to the right are used, so your domain is still x equals all real numbers, okay, x equals r. Your range, however, is different. If you look at this, range deals with y values. This graph never goes below the x-axis. In fact, it never touches it, which means all your y values in this case are greater than 0. Okay, all your y values are greater than 0. So in most exponential functions, they're either going to be all above or all below, okay, if you just have a regular exponential function. So your range will be either y is greater than 0 if they're above, or y is less than 0 if they're below. Okay, rate of change at the bottom from f1 to f3. Okay, so when x equals 1 to when x equals 3 is what they're talking about. We talked about yesterday, rate of change means the same thing as slope, which is rise over run. So your rise are your y values. So you're going from a y value of 6 to y value of 24. So your rise is you went up 18, okay, to get from 6 to 24. Your run are your x values. So you went from an x value of 1 to an x value of 3. So your run was 2. You went up 2. So your rise over run then, 18 divided by 2 would be 9. Okay, our next example, we're going to be given the equation, and we're going to fill in a table and the other information we just talked about, okay? And we'll add a 0 to it, okay? We'll add finding the 0. So let's go ahead and graph this in our calculator, okay? -2, 3 to the x, and we'll use a table to find most of our information. Okay, so I have my graphing calculator out. I'll go ahead and hit y equals. I'm going to type in -2, and then 3. And the x power, I need it as an exponent, so remember, hit that little caret. I'm going to simply just put an x there. Okay. I'll go ahead and hit graph. So notice on this one, this graph is actually the one that's below, so it's below the x-axis, okay, for it. And if I want a table, remember you're going to hit second and graph, and that should take you to the table. On my table, I had x values of -2 all the way to 2, so I'm going to look at the answers from here to here to fill in, okay, when I go to put them in. So I need those y answers. Now, I'm good if it's a whole number, but if it's a decimal, I need to make it a fraction. Some of you may know that that fraction right there is -2/3. Okay, but you may not know this one. So I'm going to show you how to find that fraction. Okay, so I can fill in answers from -1 all the way to 2. I can go ahead and fill those in. So I have -18, -6, -2, -2/3. So let me go back. Okay, let me go back. So I have -18, -6, -2, -2/3. And I'm going to show you how you can actually find the fraction that goes in with -2. Okay, you kind of have two options. Here's the option that works every time. Okay, I'm going to go ahead and bring up my calculator again. Okay, let me erase this. Okay, and I want to know when x equals -2, what fraction goes with it with y. So let me close out of that. So what you can do is you can actually type in your equation, okay, regularly. And I want to figure out when x is -2, I'm going to put that in the x spot like that. And that should give me the same decimal that was on my table. And it should be the same decimal that was on my table. It actually expands it out further though. And then if you remember, just hit math and fraction and enter, and it should convert that to a fraction. So -2/9. Okay, so -2/9. So let's put that in. Okay. So let's go ahead and fill out this information. Your y-intercept is when x is 0, so you can find that here, or you can find it here. It's always the number out front, so we know that's -2. Okay, or if they want it as a coordinate, it's really 0, -2. Okay, your zeros. Let me go back. I'm going to draw a rough sketch of what our graph looked like. And I believe your graph ended up looking something like this. If I remember right, it looks something like that. We already talked about that this graph isn't going to go through the x-axis. Since it does not go through the x-axis, it shouldn't have any zeros, because remember, zeros happen where it crosses the x-axis. So these are not going to have any zeros. Okay? This graph goes on forever, left and right. Okay, all the exponential ones do, so the domain should be all reals. The range, all the y values, notice how this time they're below the x-axis, so all your y values are less than 0. And then if I want my rate of change, okay, between 0 and 1, that would be this spot right here between when x is 0 and x is 1. Remember, rate of change is slope. It's the same thing as slope. That's rise over run. So my y values between here and here, okay, between -2 and -6, I am going down 4. So your rise, you're going down 4, so -4. And your run from 0 to 1, okay, should just be 1. So you should get an answer of -4 for that.